Causative properties are properties of a solution that depend only on the number of particles, like molecules or ions, dissolved in it, not on what kind of particles they are. Causative properties are like when you add people to a swimming pool. The water itself is solvent, and the people you add are particles. It doesn't matter who the people are, kids, adults, swimmers, or floaters. What matters is how many people are inside the pool. The more people in the pool, the harder it is to swim around, like water freezing at a lower temperature. The more the pool changes its normal behavior, just like solutions change boiling point, freezing point, and etc.
Lowering the vapor pressure. The reduction of a solvent's vapor pressure caused by the presence of solute, since their solvent molecules can escape into vapor. Ang vapor pressure guys, kay mao na siya ang force nga gi-release sa vapor. Ang vapor is gas, solvent, and solute. Ang solvent is mao na siya ang substance that does the dissolving. Example na niya kay ang water. And ang solute is mao na siya ang substance that gets dissolved. Ang example na niya kay ang sugar and salt. So with the presence of solute, iyang mapadecrease ang rate sa pag-escape sa solvent molecule. So mao na siya hinungdan sa lower vapor pressure.
Welcome and good morning. So today I will be discussing about the boiling point elevation. That is something that affects in our daily lives from cooking to industrial processes. Now, boiling point elevation is a colligative property of solutions, which means it depends on the number of solute particles in a solution, not on a identity of the solute, but it's simply put when you add a non-volatile solute, like salt, to a solvent, like water, you increase the temperature required for the solution to boil. And now, the definition of the freezing point depression is the decrease in the freezing point of a solvent upon the addition of a non-volatile solute. It is a colligative property, meaning that the extent of the freezing point depression depends on the number of the solute particles in the solution, not on the nature of the solute.
Osmotic pressure. The pressure needed to stop the flow of a solvent molecules through a semi-permeable membrane from a dilute solution to a concentrated one. Osmotic pressure is the pressure needed to stop the flow of osmosis. Now, osmosis is the movement of water molecules through a semi-permeable membrane from an area of low solute concentration to an area of high solute concentration. So here, the semi-permeable membrane is this thing in the middle. The water passes through that, which is called osmosis, and raises the solution level. Basically, the osmotic pressure just pushes it back and balances the water levels and keeps the shape and prevents excessive water movement. The higher the concentration, the greater the pressure.
Hi everyone, so I'll be explaining the last part of our topic, which is enthalpy and how it connects to endothermic and exothermic reaction. So first of all, to understand enthalpy or delta H, so mao ni siya about ni siya sa heat change nga ma-happen during chemical reaction. Basically, it tells us kung ang reaction ba ay baka kung mag-release og heat or mo-absorb og heat. So, if delta H or enthalpy is negative, meaning ana ang reaction nag-release og heat. That is called exothermic. So, for example, when we burn wood, the wood releases heat and energy to the surroundings. That's the reason why the surroundings feels warmer because the wood is releasing its heat. And like I said, releasing of heat is an exothermic example. So that means it is always a negative sign. So never always remember that exothermic is always a negative sign. So endothermic. Endothermic is the other way around. So it means this one is the absorption of heat. So, for example, melting ice. So when we melt ice, or when the ice is melting, it absorbs heat to the surroundings, which is the reason why it melts, because the surrounding is already warm, and the system, which is the ice, is cold. And when it absorbs heat from the surroundings, the ice melt. That is the reason why it is called endothermic, because like I said, endothermic is the absorption of heat. That is the reason why it is a positive sign. So I'll be showing math examples so that you can really understand endothermic and exothermic reaction. So now we have here the math examples. So let's begin to the first example. So first example, we have delta H equals 200 kilojoules minus 150 kilojoules. So when we subtract these both numbers, we will get a positive 50 kilojoules. So since the outcome is positive, this means the outcome is endothermic, because remember, endothermic is the absorption of heat. That's the reason why it is a positive sign. So in this outcome, we have 50 kilojoules that have been absorbed in the surroundings. So never forget that when it is positive, it is endothermic because it is the absorption of heat. Now we have here example number 2. Delta H equals 45 joules minus 76 joules. So again, when we subtract these both numbers, we will have an outcome of negative 31 joules. So in this case, we have a negative outcome. So this is an exothermic reaction, because exothermic is the release of heat, and that's the reason why it is negative. So in this case, we have 31 joules, a negative 31 joules that have been released in the surroundings. So the heat that was released in the surroundings is 31 joules. So like in the endothermic, never forget that exothermic is a negative reaction. So when you have an outcome of a negative reaction, always remember that is an exothermic. Same as this, when you have a positive reaction, that means it is endothermic. So in conclusion, endothermic is... So in short, enthalpy shows how heat moves in every reaction, whether it's giving off energy or taking it in. So always remember that endothermic is always a positive sign because it is the absorption of heat in the surroundings, and exothermic is always a negative sign because it is the releasing of heat in the surroundings. That is all from my part. Thank you for listening.